I'm ready.
Hello, everyone, and welcome to today's workshop. We are talking about Introduction to NoSQL Databases, and I'm joined by Artem Chibotko. Hello, Artem. How are you?
Hi, Ryan. Hi, everyone. Very excited to be here. This is going to be a great workshop.
Yes, it will. If you can hear and see us okay, give us a thumbs up in the chat just so we know that everything is working as we expect. Cedric says, we both sound good. Awesome. Thank you, Cedric. And hello. As I said, I'm joined by Artem. He's a developer advocate and author, data professional, and extremely intelligent man. So why don't you give your little introduction, Artem?
Yeah, I'm a former solution architect and now developer advocate at DataStax. I worked on different problems. My interests include data modeling, data analytics, data management in general. I use a number of different databases, and we're going to talk about several of them today, and hopefully it's going to be very useful for you to learn about NoSQL databases.
I think it will. As for myself, my name is Ryan Welford. I am a developer advocate as well as a front-end developer and Cassandra expert. So I'm glad to be hosting this for you today. It's not just us, though. We have a whole team of advocates and assistant people here that we've got, all around the world, and they're in the chat and they're ready to answer your questions as well. So give a shout out to them when you see them pop up in the chat. To get through a little bit of housekeeping today about the workshop and the organization. First off, we are streaming on both YouTube and Twitch, though we only monitor the chat on YouTube. Twitch is kind of a backup in case YouTube craps out on us and we need to switch providers. But most of the question and answers will be on the YouTube chat, so join us there. You can also go to our Discord. If you type in the command in the chat, !Discord, you can get a link to join there. You can also ask questions there. There will be people waiting to answer questions. And that's also a really good place to ask questions outside of workshop times to get more information about Cassandra or any other development advice. We are going to be playing a couple of games today. We're going to be using menti.com. This is a site that's completely free to use, and it allows us to do some quizzes, some fun games to learn a little bit more about you and to see what your knowledge is. And at the end of the workshop, we'll also be playing a game for prizes, so stick around for that. And we'll be starting with that Menti here in just a little bit. For some of the tools that we'll be using today, we will be using GitHub. It is the repository where all of the instructions for the exercises that we'll be doing on the hands-on portions today will be stored, and you can get a link to that in the chat using !GitHub. And we will be using DataStax Studio in a Docker container if you want to try that out for some more deeper hands-on learning as well. For our database that we're going to be using to showcase all of these different NoSQL styles, we'll be using DataStax ASTRA DB. It is a very flexible database as a service built on the Apache Cassandra project. And it provides a lot of tools and a lot of ways to kind of showcase all these different paradigms, if you will. For attending today's workshop and completing the homework that we will assign towards the end, you can earn yourself a badge, a participation badge that you can use on social media, on LinkedIn, just to show that you are continuing your learning. And it's a really cool way to show that off. We have a lot of different badges for all of our workshops that we do. And you can go to datastax.com/workshops to see what all those are and if we're doing any live workshops coming up. You can complete the homework at any time and earn yourself a badge if you want to do that. All right. With that, let's go ahead and do our first Menti quiz. This is an opportunity for us to get to know you a little bit more, to kind of understand kind of where you're at in your development experience, and we can cater our content better to you. So if you go to menti.com and enter in the code that you see on the screen there. On the top of the screen, it's 74683208. And give us a thumbs up when you are there in Menti, and you can see it pop up in the bottom right corner. Yeah, there we go. And we'll give it some time for people to join, and we'll get this this quiz started. All right, looks like we got 18, 19 people in there, 20. Awesome. Let's see how many people are watching right now. All right, quite a few. We'll give it a little bit more time. Menti.com. Christine, the website is menti.com. And the code you should be able to see at the top of the screen. And also in the chat. Should have just come up. All right, I'll wait until there's about half the people, half the viewers. Don't want to take up too much of our valuable time. I'll go ahead and get started. You can feel free to join at any time. You can join in the middle. Just be sure to be here at the beginning, at the end of the workshop, where we'll do a game and you can win prizes. All right. I can press I, can't I? There we go. Oh, it's kind of covered up. In any case, let's get started. First question is, where are you from? We are a global company. We have people from all over the world, and we'd like to see where our viewers are from as well. It's really cool to see where people pop up. All right, so we're from India, lots from the US, some Europe. I think I see Cedric in there. Ooh, someone from South Africa. That's a new one. At least for me, I haven't seen one yet. All right. Someone from the Philippines. That's awesome. It's really cool to see everyone from all over the country, or all over the world joining us. It really makes us feel like we're reaching out to a wide audience. So I appreciate it. Awesome. All right. So moving on, have you been to any of our workshops before? Like I said, we do lots of different workshops. We run them every week, sometimes multiple times a week. Looks like most of you are new here, which is great. Hopefully you like what you see and you can check out some of our other workshops. We record all of our workshops as well. So if you are interested in seeing any of the content, you can certainly find a recorded version or even a standalone on-demand version that's a little bit more streamlined. But warm welcome to everyone who's new, and welcome back to everyone who has been with us before.
Yeah, thank you for joining.
Next question is, what is your experience with NoSQL databases so far? Have you never used them, less than a year, 1 to 3 years, and so on? Looks like most people have never used them. Pretty expected. It is an introduction workshop, yes. So that it's expected. Looks like we have a couple of people who are have used it more than 5 years. Maybe you can help us answer questions. Fantastic. Awesome. All right. Have you ever used Apache Cassandra or AstraDB? If you've been to our workshops before, you are most likely have used both of those, AstraDB specifically. But Apache Cassandra is a NoSQL database. It's a certain flavor of it, and AstraDB is a database as a service built on top of it. So awesome. So if you've used AstraDB, then you've definitely used Cassandra, right? All right. So I assume it looks like the same breakout as whether you've been to our workshops before. So that's expected.
There is a strong correlation there, yes.
Strong correlation. You are the data scientist, aren't you? All right. Well, thank you so much for answering those questions. It really helps us kind of understand our audience a little bit better. Keep Menti open, because we'll be using the same room for our game later, where we'll be able to win some prizes. So you want to be able to get to that quickly so that you don't miss the first question, or you'll be at a disadvantage. All right. With that, go back. With that, I am going to hand it back over to Artem for our main content. and he's going to talk about NoSQL databases. So take it away, Artem.
Yes, thank you, Ryan. Great introduction. So we only spent 10 minutes on that organizational part, and we have all the time we need to focus on the meat of this presentation. What is NoSQL? And 4 types of NoSQL databases: tabular, document, key value, graph. So the exciting part here will be that you will be able to try those databases. You will be able to create a tabular database, insert some data, and retrieve some data, similar for document and key value. And I will do a demo along with you. So if you prefer to watch a demo, that's fine. I will be helping you to get started, but you will see it's going to be quite easy. In 5 minutes, you will be able to load insert a few rows in a table, or load a few documents and be able to query them. Okay, so the first things first, introduction to NoSQL. So in general, since most of you new to NoSQL and probably to relational databases and other types of databases, I'm going to give you an idea what those are. So in general, a database is just an organized collection of related data items. They are related because they belong to specific enterprise, specific domain, specific application. And sometimes also by database, when we say database, we refer to database management system, which is just a software that is able to manage our data collection. It knows how to write data, how to read data, how to index data, and things like that. So it does some operations for us. Okay. Databases may have different data models, and by data model, these are some of the types of different databases that we know of historically. So in 1960s, long time ago, we had navigational databases that were of 2 kinds: hierarchical and network databases. And you can think about those as really like a hierarchy, right? Like a tree. On network is more like a graph. So that was the beginning of databases. So there were no good query languages. Each time you have to retrieve data, you would have to write a program. So they were kind of difficult to use, work on large mainframes and things like that. So not many people had access to those. Now, in 70s, there was a burst of relational databases, and the relational databases are still here. They are very popular, and one of the reasons why is because they were standardized. There was relational algebra, there is a structured query language, and things like that. So that's probably still the most popular type of databases. And there are a couple for online transaction processing. There are row-oriented relational databases. For analytical processing, there are column-oriented relational databases, but we're not gonna need to go into details there. Then in 80s, I believe there were object databases. They were trying to resolve the problem that relational databases had. They had the mismatch of data structures in the database versus the application, and they didn't become very popular. So the next one, the truly popular one, we have NoSQL databases or NoSQL databases that we're gonna introduce today and talk about them, and we'll try them out. So there are 4 different types: tabular, a white column, document, key value, and graph. And finally, many databases right now support multiple models. So this is classification of databases by data model. So many of them actually support multiple models. Like the one we will use actually supports 3 different data models, and they're called multimodal databases. Now, databases by deployment model, we have single machine databases. We have databases that work on clusters of machines. So these are distributed databases. We also have databases that are deployed on premises. So they are basically working in some data center that belongs to an enterprise. But there are also cloud databases that are deployed to public clouds, and those can be deployed on virtual machines, or they can be actually databases as a service. So essentially, the database is provided to you as a service. You just using it. You may not even need to operate it and manage it. So there are fully managed services, and the best you can get is a serverless or auto-scalable database. In that case, why it's the best is because you basically don't need to worry about any operations there, and if you need more capacity, it will be automatically scaled for you. If you need less, you use them less, you have less number of writes and reads, then it's going to be scaled down automatically for you. So you're actually saving money by using serverless database. Okay, so why not relational? Relational is still the most popular database, and but they have pros and they have cons. One of the biggest pros for relational, they have been here for a long time, and they are well standardized. They have a great foundation that is helpful to create powerful optimizers and things like that. So they are based on relational model. They have like formal relational algebra and calculus that is used in query optimization. They have minimization theory, and then finally, the most important thing probably is structured query language. So it's a standard language. It has multiple standards that are being revised and features being added to it. Besides that, it has ACID transactions. If you're new to databases, maybe you never heard the ACID. It stands for atomicity, consistency, isolation, and durability. So these are transactions that exhibit those properties, which are important, but we will not have time to discuss them here today. Also, relational databases are frequently referred to as integration databases that are shared by many applications. So that's somewhat different than NoSQL database. We'll talk about that soon. Disadvantages of relational databases. They were designed to run on a single machine and scale vertically. And normalization theory, relational algebra, very powerful tools, SQL, very powerful language, but it was designed to have all the data together so you can quickly join or union or intersect the data and get an answer. So this is not the, so they will be harder to scale horizontally on a distributed cluster. Another problem with relational databases is so-called impedance mismatch between the relational data model and application in-memory data structure. So essentially, we have tables versus we may have objects, classes in applications. So that another issue that we have with relational. So why NoSQL? Why these databases actually came to existence? Primarily because of some performance and scalability challenges that relational databases were not able to address. They were too slow to deal with large volume of data, high velocity of data, and different kinds of data, so which is variety of data. So we have this big data and CV as one of the reasons why there were new kinds of databases invented to deal with those challenges. And we needed to go from single machine to a cluster. Okay, so the data volume in zettabytes shown on this graph, the data grows very quickly these days. Just to give you an idea, 1 zettabyte is going to be 1 billion terabytes. Okay, and we can see it's not a linear growth based on this chart. So the amount of data grows quickly, and we need technology to be able to support that growth, to be able to store that data and query it. So the NoSQL term, the origins of this term, so it came to existence in 2009 when there was a meetup as a meetup name and hashtag to denote or to refer to databases that at that time were not relational model based and didn't support SQL. So that they were non-relational databases, and they were Bigtable, DynamoDB, that still exists today and in use, and Cassandra, MongoDB, and others. Okay, sometimes nowadays we refer to one interpretation you can find is that NoSQL stands for not only SQL, because many NoSQL databases now support SQL, but not only SQL also may kind of mean that even relational databases can support SQL and some other query languages. They frequently support some kind of graph language, or possibly even some API to deal with JSON documents and so on. So what is really NoSQL? The term may be not the best term, but think about NoSQL databases as databases that can meet high growth challenges. And these are the common characteristics that you can find about them. Non-relational data model, run on clusters. They globally, geographically distributed. So meaning that you may have a data center in India and data center in the United States, and that data center, two of those data centers, they constitute one cluster that runs that database. So the data is distributed across geographically, globally, and so on. High throughput, they can handle large number of transactions. Okay. Also, horizontal scalability. So you can basically add more nodes to your cluster, and you will have better performance. You are able to handle larger amount of transactions or store a large amount of data. So they are also frequently based on open source or open source systems, and they are bound by the CAP theorem that we will mention soon. Okay, we'll briefly talk about what it is. So relational versus NoSQL. Relational has a standard relational data model and language SQL. NoSQL has variety of data models. So we're going to talk about tabular, document, key value, and graph. And there will be different languages and APIs we can use for those. Then relational has asset transactions. NoSQL usually has lower guaranteed transactions, like sometimes you can find them, they're called lightweight transactions or other types of transactions. Now, relational is an integration database. Multiple applications will use that database, will store their data in that database, and they're not necessarily intersecting. But NoSQL is usually application database, so it means that for each new application, you may create a new database instance, and it will handle data for that application only. Okay, so relational design for single machine, NoSQL designed for a cluster, relational hard to scale. They scale vertically, so you have a larger machine each time. You add more memory, more CPU, more disk. NoSQL easier to scale because you simply add more machines into your cluster. Okay, and finally, NoSQL is usually better in terms of database application compatibility. Now, a few brief words about the CAP theorem. So we said that NoSQL database is usually bound by the CAP theorem. What is this CAP theorem? So CAP theorem states that there are these three properties: consistency, availability, partition tolerance, and a distributed database can only have two of them. So it can pick two of them. It cannot guarantee all three of them. And because we're talking about distributed database working on the clusters, they usually all choose partition tolerance as one property. Partition tolerance means that, okay, you have 10 nodes in your cluster and one of them is not available, or maybe several of them due to maybe network failure or even just node failure. So in that case, will your database continue to operate if you lose some nodes or they become unresponsive or the connection to them is lost? Will your database still operate or not? So because we are talking about databases working on clusters, partition tolerance usually is something that database chooses. And then the second property, databases choose either availability or consistency. So availability refers to database will always respond, but may sometimes give you previous value or stale value for your data. So why would it do that? For example, if you write in your data, you insert in your row, and the node that you inserted it to, maybe something went wrong, it got disconnected, it's no longer response. So you cannot retrieve that latest data from that node. So you will be able to data from another replica node. So that's kind of the trade-off of using availability, trading consistency for availability. So you may not always get consistent data. Sometimes we say they eventually consistent data. And the other consistency, the other property, so you will choose that one if you want to make sure that you always get the most recent data or an error. So if you get an error, means your database is not available. So you're trading availability for consistency. So given this, these are some examples of NoSQL databases that work that pick, for example, they're called PA. They choose partition tolerance and availability, like the one we will use today, ASTRA and Cassandra and DynamoDB and others, versus there are some that use CP, consistency and partition tolerance, like MongoDB and Redis and Bigtable and so on. Okay, so this is maybe a little bit more advanced topic for the intro, but now you know that there is a CAP theorem that is important in the NoSQL world. So today we're going to use this database called ASTRA. It's going to be a database as a service in the cloud, and it's serverless, it's auto-scalable, it's state-of-the-art database. So essentially, there are no operations for you besides maybe being an administrator, doing like security operations, but you don't need to create a cluster. You don't need to worry about adding nodes, maintaining those nodes in the cluster, maybe decommissioning nodes and things like that. All of that is taken care for you, and behind the scenes, today you will get 3-node cluster. If you're gonna exceed if you're gonna use it a lot and will exceed certain thresholds, then automatically nodes will be added to that cluster. And once your workload becomes smaller, the nodes may be automatically moved to a cluster. So it's a great database which does everything for you in terms of the operations, but you still have to worry about how you're gonna model your data, what API you're gonna use for your application to interact with the database and all of that. So it's multimodal. It works in multiple clouds. It can work in Google Cloud, in Amazon, and also Azure clouds and others. Then it supports tabular, document, and key value data models that we're going to use. And it's based on open source Apache Cassandra. So today, so the database is going to be free for you to use as long as you are not using 20 million operations per month. So you get each month you get $25 credit, and that's enough for you to basically do around 20 million writes and reads into that database. So we are not going to exceed that in this workshop, and you're not going to probably exceed unless you really deploy some application that does a lot of writes and reads. So we're going to use SQL console, which is one tool that uses SQL to work with our database, and the other tool will be Swagger UI, which we will use to work with JSON documents. Okay, there are other interfaces, and for the sake of the time, I'm not going to talk about them yet, but if you want to learn more, you can always go to ASTRA.com to learn about other APIs. So, done with introduction. Now it's time to try this database. And to do that, you can go to this link and follow the instructions on how you're going to create an empty database first. Okay, and I'm going to concurrently show you how this can be done. Okay. Okay, so that link will bring you to this document, README on GitHub. Okay, and this is the first hands-on that you will be doing. Okay, and I can do that with you as well. So the first thing, you need to create an ASTRA DB instance. Okay, an ASTRA DB instance. So I'm going to open it in the new tab. What am I getting here? So I can either sign up or sign in. Okay, sign up or sign in. In my case, so you can sign up with your Google account or GitHub account, or you can register using your email. Okay. So in my case, I already have an account, and I will sign in with Google. Okay. And this is what kind of UI you will see. You will have the current plan free, so there is no need to use credit card. You will not be charged for anything. You're gonna just use it for free. And the next step you need to do, you can create serverless database. Okay, give it a name. Based on our instructions, we want to use workshops as a name, and the key space we want to use will be NoSQL 1. Okay. The second step, you can select the public cloud that you want to use for, and to where you're going to deploy your database. So I'm going to select Google Clouds. I'm in North America, so I'm going to select, probably closest to me will be Virginia. US East 4, and I'm going to create database. So what happens next? I actually do have two of them, workshops databases. One I created before, but they have different IDs, same name, different IDs. So you will have, your database will be pending, and at some point it will become active. Okay. So I'm gonna wait for you to let me know if you have any questions, or if you were able to complete this simple hands-on. So we're just creating an empty database, and we will be able to add data to it later. So the question I have, what does serverless data really mean? So the data is stored in a database. A database software runs on a server, right? So when we say serverless database, we're saying that that server is hidden from you. So the server is fully managed by the system, and you don't know whether you have 2 servers, 3 servers where your data is stored. And serverless also refers to also comes frequently with automatic scalability. So if you need to have 1 million transactions per second, you may need to have 4 servers. But if the workload increases to 2 million, you will need to double amount of servers. So that is done for you automatically behind the scenes. That's what auto scalability means. You're not managing those servers. So it's not really serverless data, it's serverless database. Okay. There are also serverless compute. Okay. There is also serverless compute that allows you to deploy an application, deploy code without managing the server. You don't know what kind of server is used for that, and it also can auto scale. Now, my database is active.
Hey, Artem?
Yes.
We're having a question, a request to go over the database creation steps again.
Okay. So once you sign up, you have this create serverless database button here. So just click it and then select the database names. In our case, this will be workshops. And the key space we want to use, and you should use the same one, okay? Because our instructions, the code we will provide will assume that you're using this key space. So key space is just like the collection of database schema. We give it a name, that collection. We will create tables inside, or we will create document collections inside, and things like that. And then you need, second step, select the cloud provider. So you can pick whatever you like, and probably Google Cloud seems to have more free. Again, these are free regions that you can use, but for the paid version there are more regions. So in my case, this one is the closest. I select it and do the create database, and that's it. Okay, that's it. So now I have 3 workshops, but they have actually unique IDs. I will only use one of them for this exercise, for this workshop. So you will have pending. It will turn to active soon. Again, the instructions are here. You can always do it after the workshop for your homework. So this is pretty simple. Okay. So in this workshop, we're going to use 4 different types of NoSQL databases. One of them is Tabular, the other one document, key value, and graph database. First 3 we will use ASTRA DB, the one which we just created empty database there, and we're going to use it for tabular data and key value data and so on. Okay, and for the graph database, we will use DataStax graph. So it's not part of ASTRA DB. It may become in the future, but I will probably show you a demo, which will be an easier, because this is not the database as a service. Okay, so also for all these 4 different types of databases, I'm going to use the same example. So imagine we have users that each user can have multiple accounts, and each account belongs to exactly one user. User is uniquely identified by ID, has name and email. Account uniquely identified by ID, has type and balance. So 3 different attributes, very easy. 3 different attributes for user and 3 attributes for account. And user can have many accounts. Each account belongs to one user. So this is like our schema. Actually, it's the model. It's a data model called entity relationship model. So it's very generic. Now, how are we going to store this, right, in different types of databases? We will also use this data. We have Alice with this email, and Bob with bob@example.org. So we have two users, Alice and Bob. Alice has checking and savings accounts with balances 2,500 and 1,500, and Bob has one checking account with balance 100. So we have three accounts. Two of them belong to Alice, one belongs to Bob. So this is the data we are thinking about to use and how we're gonna store it in a database. If you're familiar with relational databases, then you know that you will probably create two tables to store the data. One table for users, okay, where you will store user ID, username, and user email. We have Alice and Bob, and you will store three accounts in a different table called accounts. So we have two checking accounts, one saving accounts, but there will be also reference to the user that these accounts belong. So this is called foreign key in relational database, if you're familiar with that. So essentially this user ID connects to this user ID, and that's what allows us to join data. So this is how you will do in relational database, okay? But what we're interested in today, how are you going to do it with tabular database, how are you going to do it with document database, how are you going to do it with key value and graph. So the same example we're going to use to model that data in 4 different types of databases, and we are going to use hands-on. We're going to use exactly the same data in our hands-on. So let's start with tabular databases. Okay, let's start with tabular databases. So the data in tabular databases is modeled and stored as tables. There will be columns and rows. However, these tables are different from relations or tables in relational database because these are usually denormalized tables. So they nest data based on how the data is related so that we can retrieve that data together with one single request. And that's going to make it more efficient. We don't need to join data from multiple tables. We're going to store it together and we will retrieve it very quickly and efficiently. So that's why they can scale and perform. So there are primary keys, partition, clustering keys there. We will see an example in hands-on. There may be indexes and materialized views and all of that. And the queries that we're going to use will be SQL-like queries, but they will look like SQL language, structured query language, but they don't have joins. They don't have, for example, the more than one, right? No union, no intersection, no difference, and things like that. No nested queries. Okay, so the efficient access pattern there is to retrieve one row, one partition, subset of rows from one partitions, and things like that. The use cases for these databases, they're general purpose databases, just like relational, even so the data is modeled differently. So there are many similarities in terms of use cases. Where you use relational database, you usually can easily replace it with tabular database. Some examples would be just transaction processing, real-time transaction processing, IoT, time series, content management, e-commerce. We had just recently 3 different workshops on e-commerce that used these type of features. So here in this example, we store in all information that we have about users, accounts in one table. Okay, so we have user ID, name of that user. Okay, and well, email is not here. Just We didn't retrieve it, just smaller. But then there is also account ID, account balance, and an account type. So all this information stored in one table. This is how we can retrieve information for just one specific user ID. So select account type, account balance from accounts by users, where user ID equals something. So given user ID, we can retrieve all information about all accounts for that user. We are not doing join between users and accounts. There is only one table to manage this data. Okay, so this is how this table will look like. Okay, we have all of the now email is present here as well. What you can notice that this user ID, and in the previous example too, so there is a strange combination of digits and letters there. So this is so-called UUID. So this is universal identifier that is frequently used in distributed systems to guarantee uniqueness. So it's generated automatically and it guarantees uniqueness. There are different types of UID. You can read about them if you're interested. So similar, the account ID is also another UID. What you can see here, this user has one name. It's not stored twice, actually. It's stored one time. And has email is stored once as well. But then, so it's basically the user ID defines a partition with multiple rows. Okay. And in this case, we have two rows, one row for each account of this user. Okay. So we have the one row for each account of this user. So a savings account, checking account. And basically, we nested our accounts into the user partition. So how is it done in practice? Okay, again, we will go back to our hands-on. Okay, let's go back to our hands-on here. And we'll do this second hands-on for tabular databases. Okay, so the first part here, we will simply, so we just created an empty database with key space NoSQL 1. And the first part will be to describe describe the key spaces and find that key space that we have. So how are you going to start? Again, I'm gonna go back to ASTRA DB. Okay, and we'll select my workshops database. Okay, and we'll click on the SQL console. So there you can see there are multiple tabs here. We will use Connect tab today. We will use the SQL console today as well. So at this point, we're going to use SQL console, which is basically the shell, web-based shell that allows us to interact with our database. And the first interaction, again, the first interaction we want to do here is this describe key space. So I'm going to copy it and execute. So you can see there are multiple key spaces already in our empty database. The one that we created is NoSQL 1. All other key spaces are essentially needed for the system to function properly. Okay, simple enough, right? Simple enough. So we are going to use this key space that we created. Okay, so let's go back to the instructions. And we are going to create our first table. But notice before we create this table accounts by user, okay, before we create this table, we also have the use NoSQL 1 statement, which basically we will select our key space as a default key space that we will be working with. So copy this, insert. So what are we creating here? Okay, what are we creating? We're creating a table called accounts by user with these columns: user ID with UUID data type, account ID, UUID, account type, balance type, account balance username, user email. So these are data types, text, decimal, text, but also there is this special keyword static, which tells that these two columns, username and user email, they are shared by all rows in this partition. So essentially, we have the partition, primary key defined as a partition key, user ID, and account ID. So partition key allows us to tell the system that the data should be distributed based on this partition key. It should be partitioned based on the value of user ID. But then rows within the partition should be identified by the clustering key, which is account ID. Okay, so looks very similar to relational table, but it's different because it's distributed. It's partitioned table, essentially. So what's next? Okay. At this point, we can describe key space and make sure that the table we just created exists. Okay. And indeed, we have the information about our key space and replication factor and strategy, which we're not gonna go into it. And this is our table, and you can see there are a bunch of other things added to it. These are all different settings that we don't need to know about today. But this is our table, just the way we created this table. Okay. So what's next? We are going to insert some data. Essentially, we are going to insert 3 different rows, and these are our users and accounts. We're going to insert account for savings account for Alice, checking account for Alice, and checking account for Bob. Okay, so I'm going to copy this. Okay, inserted data. And of course, I want to retrieve that data and see how it looks like now. Okay. So just like in the slides, we had these 3 different rows and 2 partitions. So there is partition for 2 accounts for Alice, partition for Alice. This value Alice and email is not stored 2 times. Actually shared by all rows in partition. So it actually stored once. Okay. That's why when we were inserting the second time, we did not specify, we specified the account information, but we didn't specify email and name for Alice. Okay. So, but of course, this query, we retrieve everything from the table, is not the most efficient query. In fact, in production, you should not use this query. The queries that you should prefer are the queries that retrieve either single row based on primary key, like this one. So we selecting information about email, account type, account balance from our table, where user ID is known and account ID is known. So we essentially return information about one specific account, and this is very efficient query now. Okay, it's very efficient query. It just goes to one specific row. Another type of efficient queries will be retrieving one one specific partition. Like in this case, we're going to retrieve partition for user with this ID, I believe. So this should give us 2 accounts for Alice, essentially. Okay, so we get 2 rows from that one partition for user Alice. Okay. And that's in Tabular. Yes. So this is what we need. created a table that stores both users and accounts in the same table instead of creating two tables. And we inserted 3 rows, and we are able to query the data. Very simple. If you know relational databases, you kind of see that the syntax is familiar. You're dealing with tables. There are also indexes here. There are materialized views. Actually, not in this version, but there are indexes that you can use to index your data to query based on index as well. Right now, the querying, the major difference is that you can only query based on primary key columns, but you cannot, for example, query based on user email or username or account balance. But if you index those columns, you will be able to do that. Okay, but this is an intro. We're not going to the complex stuff, right? So I'm going back to my slides. Okay, so the language that we just used for with tabular databases is called CQL, Cassandra Query Language. So that's one of the questions I see in the chat. So the next type is document databases. What are those document databases? Well, document databases, they store semi-structured documents, usually JSON documents, and they are frequently referred to as schemaless databases, but it's more of a marketing term because schema of the document is embedded in the document itself. That's why it's called semi-structured. It's still structured. Schema is a structure. So it has schema, but it's more flexible. It's semi-flexible, right? Semi-structured. And sometimes basically the schema is embedded into the document. The JSON document will have the attribute names, it will have data types like arrays. You will read that data. You will read that data along with schema. So it's sometimes called referred to as schema on read. Okay, but indeed you will see there is some flexibility with the schema, and there is some advantage that you don't need to think about rigid schema with data types in advance. You can simply insert something that you have in terms of JSON document, and it's going to work. But of course, how you structure your JSON document will be important for the final product. Of course, you still have to deal with schema and data model. So the queries that I use there, you will either query a document by ID, or you will query based on the fields or attributes that are part of that document. Okay, so the use cases, it's also kind of general purpose database with flexible schema. It provides excellent mapping between database and application data model, object, JSON document, and there are many libraries that lets you do the serialization and deserialization, things like that. So content management, catalogs, mobile apps, and applications like this. Okay, so what we're going to do, so here's an example. We have the users as a collection of documents, and there are 2 documents, JSON with ID A, JSON with ID B, and we're going to query them based on, we want to find a document where there is a name attribute with a field with name and value Alice. So this is how it may look like in MongoDB, AstraDB, and we're going to try AstraDB just now. Okay. So you will be able to execute that specific query. So this is for our running example. The document data model will look like this. Okay. So we have the ID of a user, name of the user, Bob, email, and then accounts will be array with, in this case, with just one one element where we have the ID of an account, type of an account, and balance. In case of Alice, we have an array with 2 elements. We have the checking account and we have savings account. So quite easy, but also what's common between this and our tabular example? Okay. The common part here is that we still nested our accounts into user documents. And remember, we had the table accounts by user, so we nested our account rows into user partition. So there are similarities, and when you decide how you're going to nest this data, you still want to think about how you're going to retrieve that data, what types of queries you will use, and so on. But anyway, for the introduction, we're going to work with those 2 documents in the slides, and we're going to insert them into our database and retrieve them. Okay, I'm going back to part 3 of the hands-on. Okay. Okay. So if somebody having an issue with the creating database, maybe try a different region, just create a new database. Okay. So somehow I just created in front of you 2 of them. I didn't have any issues. So any case, anyway, so let's look at our document databases. Look at our document database section, and so there is an optional part here. So the Cassandra and AstraDB does support the JSON queries. So you can, you can insert your JSON directly. So we can insert into our table accounts by user as JSON, and we will be able to retrieve as JSON as well. So this is one approach, but I'm not gonna talk about this approach. I'm gonna skip it as optional. And instead, we will use Swagger, which is a tool that supports document API for our AstraDB database as a service. Okay, but to be able to use Swagger, you will need to have you will basically need to be able to authenticate into AstraDB using a token. Okay, so this is something that you will first need to create a token and use it to be able to connect to AstraDB using the Swagger application. And Swagger application is a web-based application, so it has web UI. You don't need to install anything and all of that. So the first thing, we will have to create a token. So let me show you. You can follow this link, how to create a token. And token, again, is just basically for security, for authentication reasons. So this is, I'm going to show you how to create a token really quickly. It's not going to be, so I'm going to go back to dashboard. So it's going to be a simple procedure, and it will hopefully save you a few minutes of reading the document if you just follow carefully this simple procedure. I'm going to go back to dashboard, find my database here, and click on these 3 dots and click generate a token. Okay, generate a token. Okay, so here I'm going to select role for that token, and I'm going to use database administrator and click generate token. Okay, now this information is secret information, so you should not share it with anybody else, and I unfortunately have to show you. But I'm going to copy this, and I'm not going to, and I need to download it and be able to reuse it later as well. So we will use it in multiple requests. So I need to have it handy. So one way I can probably just open another tab. Okay. So I still have my token available here. I can copy it multiple times. But what I will do next is still follow these instructions. I'm gonna go to the connect section and find Swagger UI. So I'm going to my workshops database and going to this connect tab. Okay. Document API is the first one. And this is the link to launch Swagger UI. Okay. So I'm getting the message that we are maybe going too fast. So I'm going to do it again. Okay. For this hands-on. Okay. For this hands-on. So let me go back to ASTRA-DB. Okay. So for this hands-on, we're going to create a document database. Using the same database as a service, we're going to use document API to insert documents and retrieve documents. So the first thing I need to do, because we're going to use the Swagger UI, which is just a web-based tool that allows us to send requests to our database. So it's our client, web-based client, that's going to interact with database, but we need to authenticate to that client. Basically, we need to log in with that client, right? So the thing here is I need to first create a token, security token, authentication token, to be able to authenticate. And the process is very simple, right? Once you on this dashboard page, okay, you can find your workshops database and click on 3 dots next to it, and then choose generate a token. Okay, so I'm gonna give you a few seconds to find that generate a token link. Then you click on generate a token and you select. So this is called application token. Okay, and you will select the role that will be used for authorization. So essentially, what kind of privileges will that token come with? In our case, database administrator, that's a lot of privileges. Okay, you can see these permissions for this role. Okay, and I have a bunch of those tokens. Some of them are used with services, applications, and some of them are just were created to do demos like this. So I'm going to click generate token, and this is the token itself. Okay, so I'm gonna copy it at this point. I'm just gonna copy it, and I'm not gonna, either you can download this token or you can just keep this tab open. Okay, keep this tab opened, but don't share it with anybody. I have no choice, I'm sharing the screen. But don't share this information with anybody. This is a secret that like a password. Think about it as a password, but generated for you automatically. So now what you can do is you can So one thing, I will not close this, so I can go back and copy it again. So I will open another tab and close the previous one. Another tab with AstraDB. And now I want to find my Swagger application client. So I will first select my database, go to Connect tab. In the Connect tab, the document API is the first one, and the launch in Swagger UI is right here. Okay, so this is the link for you to launch that UI. You can click on it. It opens in a separate window. So essentially, this is a web-based client that will interact with your database now. Okay. Let's go back to instructions. And the first thing we want to do is create a new empty collection. Okay. And that collection will have this name. It will have name users. Okay. So what we need to find the endpoint, API endpoint that looks like this in Swagger. So it's a v2 namespace, create a new empty collection, and we will specify namespace, which is equivalent to key space. It's NoSQL 1. And then in the body, we'll say this is the collection we want to have. So in Swagger, I'm going to look where this empty collection is. And here it is. Create a new empty. Okay. Create a new empty collection in a namespace. Okay. Now remember the token. Each time we send a request, that request needs to prove that it has permission to do something in the database. That's the role of our token. So I will click try it out first to be able to edit these fields. This is my token. Namespace ID is NoSQL1. Should be the same for you. And then here we will need to say that it's going to be the name of this collection, that the collection of documents is going to be users. Okay. So after you have these three values, again, this is a second endpoint in the Swagger UI. So at this point, you can just execute. So now request is being sent from this client to your database. Okay. And you can see the response for this request. It has code 201. What does it mean? You can look below it and you have all basically the map, the legend for all the responses. 201 means it was created. So there were no issues. If you didn't have the correct token, you would get unauthorized, or you didn't have the permissions. And there are other responses where you would get errors. If you get 201, then you created your collection successfully. Okay, so this was the first one. And we need to execute a few more. So let me wait a few seconds for you to catch up, because I'm going to go a little bit faster after that.
Artem, it might be helpful to zoom in on the web page, especially on Swagger UI. The font is somewhat small. I'll make sure that people can read it. Yeah, just okay. Command plus or yeah, perfect. That's good.
Okay.
Thank you.
Of course. So the question I got, all data of a user on the same partition. Indeed, that's the case for our tabular example. It's going to be the case for our document example on the same partition. Okay. So anyone having issues with the Swagger? Anyone is successful? Okay. Okay. So I got responses done. Yes, successful, success. Great. So we can continue with the next one. The next, we will create new document. And this is the endpoint we need to find. Create a new document in specific collection. We will specify again namespace, NoSQL 1, users as a collection, and this is the body of the document. Okay, so let's look for this again in Swagger. I'm gonna create a new document. Okay, so this is the fourth one. So try it out is the first thing. I will copy my token. I will use NoSQL 1 as namespace. Collection, we just created users. And now I need to add JSON document. So at this point, I will have to go back to instructions, copy my document. This is for Bob. Okay. And I will insert it here. Okay. Again, this is the force endpoint, token, key space, namespace, collection we just created. And this is the sample document. That is the same document we used in the slides. The order may be different, but the data is the same. Okay, let's execute. The response we got is 201. What is 201? 201 means created. Good. And the response body has the document ID. Okay, so this is the document ID we may need to use to retrieve the document. So we may download it, we may do something with it. Okay, at this point we don't need to do anything. Let's look at the next one. The next one we will create the second document. So I'm gonna copy this second document for Alice, go back to Swagger UI, and I will simply replace my previous document with the new one and execute again. So second request, collection, namespace, token is the same, different document. Execute, and we got the response 201 and different document ID. Okay, very, very easy. Okay, very, very easy. Similarly, when you develop your own application, right now we're using web UI, a client with web UI, but when you develop your own application, you will have similar types of requests that you will be sending and you will be getting response. Okay, so let's retrieve document by its ID. We're gonna use get endpoint, which looks like get a document by document ID. Okay, so I will need this document ID. Okay, I will copy the document ID I got for Alice document. I will just copy it here, so I can reuse it. Okay, I will look for the get. So it's gonna be somewhere towards the end, I believe. Oh no. Okay, get a document. So it's somewhere in the middle. It's hard to see once I zoom in. No, it's actually towards the end. Get a document by document ID. So I just copied the document ID. I will click try it out, document ID. I need the collection, which is users. I need the namespace, which is NoSQL 1. And I need the token. So I can either find it in my previous requests, like this one, the second one we used. So there is still my token preserved here, and I can use it. Or maybe I can go and copy it again from here, which I'm doing right now. Okay, so still using token. Okay, and that's it. We don't need anything else at this point. We just retrieving based on the document ID. Okay, so let's execute. So response we got is 200, which is okay, means okay. And the response body is our document for Alice, for user Alice. So we have both accounts with all the information. Okay, and that internally was retrieved from one single partition. Okay, so retrieving by document ID is very, very efficient access pattern, but we also want to be able to find document based on maybe some field. So first, what we're gonna do, we will retrieve all documents in the collection, which is not super efficient access pattern, but we will just showcase to make sure we have both documents inserted into our database, search documents in a collection. That's what we need to find. Okay. Let me minimize this. So this is actually the third one, search documents in a collection. Okay, try it out. Still, same token, namespace ID is NoSQL 1, collection users, and execute. Okay, so response is okay, and these are two documents in the response body, two documents that we inserted, one for Bob, another one for Alice.
Hey, Artem, can you point out where the document ID can be found? Some folks are having trouble finding it.
So once you insert, so document ID, for example, this latest request I executed, this is the document ID. And this is a second document ID. Okay, but also after you inserted the document, okay, let me close this one. After you inserted the document in the force endpoint here, API call, after you inserted the document, if you look at your response, this is a document ID for that document. Okay. Okay, this is document ID. But your document ID will be different than my document ID. So you need to look at your specific response body. Yeah. So this one is longest hands-on, but we are getting close to the end. So the final one, I believe, yeah. So we retrieved all the documents, and the final one we are going to still retrieve all the documents where there is this condition, name equals, so we are searching based on the name field, and it should be equal to Alice. We need to retrieve one document for Alice. So we're not using document ID here. We're going to use the specific field. So if we go to the Swagger again, the previous one, we searched all documents in the collection. We retrieve all documents from the collection. So I already have the my token, NoSQL 1, namespace, users collection. And now for the where, I'm going to insert this name equals Alice. Okay, execute, and the response is okay, 200, and I'm only getting this document where name equals Alice. Okay, so we were able to create a collection, empty collection, insert two documents, and create those documents by document ID, or retrieve all of them, or retrieve all of them where name equals Alice. In our case, that's just one document. Okay. Okay. So we finished the hands-on, and we still have a couple more to go. So I'm gonna have to continue at this point. So key value databases. Key value databases, probably the simplest type of databases, and they essentially store key value pairs, and the values can be just simple literals. They can be collections like sets or lists or maps. They can be just blobs. They can be JSON documents. So you usually don't look inside of the value, but you retrieve just based on the key. Okay, so your lookups are based on the key, and you may even have a SQL-like language, but it's going to have a limited capabilities how you can do that. So the use cases are where you're gonna have very simple and efficient queries just based on the lookups, based on the key, and most likely nothing else. So maybe you cache in something and you retrieve it based on the key. Maybe you having user session, maybe you having the documents for users, and you're not gonna query based on name in field in the document, but you're just gonna query based on the key and nothing else. Okay, so they are much simpler, and essentially in our example, you may have the users as a users where you table or users underscore KV table, and you will be able to store key value pairs for information you have about users and accounts. You may actually store, for Alice, you may have a blob with all the information. For Bob, you may have the blob with all the information, but there are other ways to do it as well. I'm going to show we are actually going to use a little bit different way to do that. So here's an example how you may retrieve data for REAC, which is one key value NoSQL database. This is how you're going to retrieve for key with name Alice from bucket users underscore KV. For AstraDB and Cassandra, it's going to be example will be look like SQL query, select value from users underscore KV where key equals Alice. So this is one example how you're going to be able to model the same data for our Alice and Bob users and their accounts. Okay, so we basically went to the lowest level of granularity. We could have modeled is as key being Alice ID or user ID, and everything else is stored in a blob. But here we actually broke down to individual values. So we can retrieve for user with this name, or with this ID, we can retrieve name, it will be Alice. We can retrieve email, it will be Alice at example.org. We can retrieve accounts, and this is a set of 2 account IDs, okay, and so on. And then you also have the accounts stored here, account with this ID, this type. So this is the whole literal is a key, and this is the value check-in, and this is the value for balance, and so on and so on. Okay. Okay. So we should be able to complete this hands-on really quickly, because this is the simplest one. So what I will do, I will go back to the token, and because I exposed it, I'm going to delete it right away. Okay, I'm gonna delete the previous one too, because I exposed it as well. Okay, so, and now we can go back to dashboard. Actually, yeah, select your database again for this exercise. And let's go to SQL console. And we will create in our NoSQL 1 key space, we're going to create table users underscore KV with key and value columns. So I'm going to copy. Insert. We have the table. Okay, I'm going to insert all those values you saw in the slide. Remember, user, ID, name, and then the value is Alice. So exactly the same data you saw in the slides. And now I will be able to create, for example, I can retrieve the information for specific key. In this case, it's account with ID, and we are interested in balance. Okay. So I'm getting these value. And there are other, but we don't need to go through all of them. But essentially, yeah, let's actually execute. Let's retrieve everything from the table so you see that it looks just the same way we showed in the slides. So all our keys, all our values. Okay. And basically you will retrieve and you will update and you will insert based on the key. So it should be very straightforward. So we can, I think, move forward without finishing the rest of the. There are a few more statements you can try on your own, but essentially each time you're going to deal with a particular key, and you will either update the value, or you will insert, or you will delete, or you will select. Okay, so quite straightforward. Okay, that's good. And so the last type of NoSQL databases we'll talk about is graph databases. And this is probably the most complex type, because it involves a lot of the data structure is the most flexible, but also kind of most complex in terms of how you can use it, how you can query, traverse it, and all of that. So the graph is very, very flexible, versatile, generic data structure. You can model anything with graph, basically. There are vertices there, edges, and properties. So the properties are attached, can be attached to vertices and to edges, and they basically describe those vertices and edges, right? And there are different types of graphs. Property graph is the one we will be using today, but there are also so-called RDF graphs, sometimes called knowledge graphs, or subtype of them. So that's the data model is still quite similar. There will be nodes and edges there, and different types of properties as well. Okay, there are also different languages. So Gremlin is the one we're going to use today. There is Cypher, graph query language. There is GSQL, there is Sparkle used with RDF graphs. We're going to use Gremlin. It's a graph traversal language. This is how it looks like. Okay, this is how it looks like. The graph use cases for this database, they usually, when you use them, they are more versatile, more complex type of computation usually when you focus on those connections, edges, links, relationships. So you usually traversing a path or traversing a neighborhood in the graph. Like this movie Alice in Wonderland has a neighboring vertices that you may be interested in. Some of them are about genre, some of them about actors or directors, some of them about users who rated that movie, and you may be interested how this movie is connected, or how one user is connected to another user, maybe through a third user, and so on, so on. So there may be a shortest path that you're looking, or there may be some kind of graph-based algorithms that you are interested in computing. So the more complex use cases, customer 360, personalization, fraud detection, recommendations, Internet of Things, and so on and so on. Okay, so different data model. We're gonna still model our example, and this is one example Gremlin query. What it does, it retrieves the vertex with name Alice, vertex for user with name Alice, and it's going to traverse edges in any direction for 800 milliseconds at most, in the hope to find a user with name Bob. Okay, so that's kind of simple way to explain. So it tries to find whether Alice and Bob are connected in our graph, and it doesn't care how they are connected, as long as there exists a path between them, and that path is simple, so no cycles, for example. So we're gonna try simpler queries than this. Okay, but this is how our data model can be represented as a graph. We have user with this ID, with name Alice and email. This user has account, so this edge represents the relationship has between user and account. And user has another account, so different edge, different vertex for the second account, which is savings account with this balance. And there is another user, Bob, who has another account with this ID, type, and balance. And it happens in our simple data model. The users are not connected, accounts are not connected, but this is because our example is very simple, right? Because in real life, there will be usually a lot of connections, right? And the distance between, like in social networks, if these are two actual people, they will be somehow connected through other people, and usually it's just through 5-6 edges at the most. Anyway, for the hands-on, I'm gonna show you just a demo, because this hands-on requires you to install things, and we don't have time for you to install, but you can follow the instructions to do it for the homework, even so it is optional. But what I'm going to use, okay, I'm gonna use the, okay, interesting, all of them. Okay, so I'm gonna need to log in, just give me a second. Okay, so this is the This is essentially a client called DataStax Studio that works with a graph database called DataStax Graph. Okay, so it's not AstraDB anymore, it's DataStax Graph. So I have an instance running in the cloud, and I have this client running in the cloud, and it has web interface, so I'm able to use it. So first thing, I will drop any schema that may exist in that graph database, and I will recreate schema for my graph. The name of the graph, I created it before. It was user. It's called users and accounts. That's the name of the graph, but it's empty. How do I know it's empty? If I look at the schema tab, there is nothing here, right? Nothing here. Now I'm going to click on the schema creation code, and I got this account and users, and there is an edge between them. So what did I do to create this type of schema? Well, I created vertex label user with these properties, ID, name, and email, and I'm partitioning my data, my users based on ID. Again, you still see the UUID like we used before, text. I created account vertex label, and these are ID, type, and balance. And also edge label has, which is going to go from user to account. So it's directed. So it's a directed graph. Property graph is a directed graph. It's direct. This edge is directed from user to account. But now you will see and say, well, user to account. But why do you have an arrow? It's a bidirectional edge. Why do you have an arrow? Well, because I created an index that will also be inverse index. Okay, so it's gonna also allow me to jump from account to users if I want to. And I created other indexes, which I'm not gonna discuss for the sake of simplicity. I'm gonna insert my data. So schema, no longer interested in it. It's very simple schema. Inserted my data, say success. Okay. How did I insert my data? I'm using one of several methods, ways to insert data. So this is called Traversal API. You can see it's Gremlin language. And I'm adding vertex user with this ID. And I'm generating ID from UUID from the string, name Alice, email, familiar, right? And I also created a label, like temporary label for me to use in this particular traversal, Alice. I do the same for the Bob. I do the same for accounts. So I'm inserting vertices at vertex account with this ID, type, and balance. And once I'm done with add v, inserting vertices, I'm adding edges. All of them are has edges, and they go from Alice to the first Alice account, from Alice to the second Alice account, from Bob to the. So this is one way. There are, of course, you can bulk load from a file, for example. Instead of just writing something like this manually. So if you have CSV file, you can load data from that file as well. Okay, nice. So let's see what I have. Okay, so this first vertex, this first traversal or query, Gremlin traversal, retrieves my graph. So I have all the data, all the vertices. So I have Alice and accounts. And you can see information about those accounts. And I can even customize the names. For example, I already customized for the user. I'm using name, but what about the account? Maybe I can use balance as a balance in, and maybe type of the account. Let's see what happens. Okay, so Bob has $1,000 in checking, Alice has $1,500 and $2,500 in savings and checking, and so on. But this is the visualization. The response you will get may actually look like this, or tabular view may look like this. Okay, so the idea of those vertices will look like this, and so on and so on. So some more interesting queries, I can, just based on this ID, I can retrieve a particular one. For example, I can retrieve the only one vertex essentially for Alice based on this ID, or I can search for Alice based on the property name. Okay, so I'm getting this Alice still vertex, or I can, once I find Alice, I can traverse outgoing edges with label has, and I will end up on accounts. I found 2 accounts for Alice. What about I want to only see the values in those accounts? I'm gonna say values balance. Okay. Oh, it didn't work because I selected. Once you select something, it's gonna only execute the selected part. So that part is not gonna work. So, okay, so I'm gonna visualize numbers for me, but this is what I got, 2 values. So I'm gonna add them up with sum. It's so-called step, Gremlin traversal step. Gonna add them up. So this is a total balance for Alice. Now I'm gonna find accounts for Alice. Okay, so I'm gonna go find the vertex with label user, name Alice. We'll go traverse has edges, we'll find accounts, and we'll see that the values for the balance is greater than 2000. I will only keep those accounts where the balance is greater than 2000. So it will give me just one account. Just one account. And the final query here I'm going to show is so there is an error there. The final query I'm going to find all the accounts. So I'm going to find Alice first, Alice vertex, and go to the accounts. Traverse has edges, go to the accounts, and group count those accounts by type. So essentially, I want to know how many check-in accounts, how many savings accounts does a user have. So these are different types of traversals that I just showed you, and these are some of the simplest one. Of course, you can do much more complex things, but we didn't even touch any shortest paths because our graph is simple. Any branching, any repetition, and things like that. Okay. And that's gonna be the end of the 4 different data types. So now we covered them. So which one should you use? For different use cases, we will use different ones. Okay, there is no one solution that fits all. Even so, graph looks like the one. It can model everything, right? So flexible, so versatile, but graph does suffer from from certain things. Like in this case, it's the most powerful in terms of handling those relationships, but it will suffer in terms of scalability, as it's going to have lower scalability and performance than other types. So more complex data model, but it's going to affect the scalability. On the other hand, the simplest one, the simplest data model for key value is going to have the fastest performance, is going to have the greatest scalability, right? And then for tabular and document, it will also, they are pretty much very similar in terms of their ability to handle relationships, and we saw that very easily with the way how they nest data in the document or in a partition of a table. But in terms of scalability, usually tabular databases have better scalability. But again, it all depends on how you model and what queries you take into account while you model the data, and how you're going to index data and all of that. Okay, and all of those things. So there are more to it. Of course, I can create a graph database that will be more performant than your tabular database if you are not going to model your data correctly. Okay, if you're not going to take into account all the access patterns that you're going to use in your application. Okay, And graph is going to be very flexible on how you can traverse your graph, traverse your data. Basically, you can compute anything you like. Okay, so what is next? And the next part, I think Ryan is gonna have a quiz on Menti. My pleasure.
Oh no, I was muted the whole time. No. Okay. I was just going over what we're going to do next. We are going to do the quiz, where you can win some prizes, so stick around for that. If you continue to have any questions about the content that we just went over, feel free to continue asking them. I know Cedric is hard at work at answering those questions as well. So feel free to continue with that. So with that, I will go ahead and move us back over to menti.com. Hopefully you still have this window open. If it will respond for me. Oop. All right. Yeah, just make sure you can go to menti.com. I'll put the link back in the chat. And you can see the code up at the top as well. And we will get this going. Make sure we have everyone who wants to join. Awesome. Okay. Apologies about the muted audio. It's always something, right? All right. So we'll get everyone in here and we'll get started. I think we have about half of everyone. Give it a couple more seconds. If you do have just a reminder, if you have questions later outside of the workshop, you can join our Discord and you can ask questions there as well. Oh, I will wait for you, Suraj. Connection lost. Refresh. Okay. All right, I'll go ahead and get started. Looks like we've settled out at a number. So, question 1. What database should you choose for high growth applications? Relational database, NoSQL database, hierarchical database, that's hard to say, or object database? NoSQL database is correct. We are talking about the NoSQL databases after all. That is the correct answer for high growth applications. All right, let's see what our scoreboard looks like. Just a note, it is you get more points the faster you answer. So make sure that you are quick on the draw as quickly as you can. All right, Cedric, questions guru is the fastest. Cedric. All right, let's move on to the question 2. We have 7 questions, so it'll take a little bit. Important benefits of many NoSQL databases are faster joins, no need to design a database schema, simpler to operate, or better performance and scalability.
That could be a tough question.
It can be a tough question. Yes, so better performance and scalability. I suppose the other options vary depending on what type of NoSQL database you're using. So not necessarily universal, but more universal is better performance and scalability. Go ahead.
For Tabular, for key value, we design schema. Graph, we design schema as well. if you remember. And for document, we kind of skipped this step, but we still structured documents to retrieve them properly, right? You remember we nested accounts into user documents, things like that. So you have to deal with schema anyway.
Yeah, that's a good point. Looks like Myrdal was the fastest. Our top three, Yanga, Millie, and Vroom. Remember that the top three, I guess I didn't mention this, the top three are eligible for prizes. So you want to get up in the top three for sure. All right. That's question 3. What is AstraDB? It is a local in-memory version of Cassandra. It is a Cassandra as a service in the cloud. It's an album by Radiohead. It is a development tool. All right. Yes, it is a database as a service based on Cassandra in the cloud. All right, let's check our leaderboard. All right, Millie was the fastest this time. Maintained second place. Yanga and Myrdal is first and third. Is it actually an album of Radiohead? I'm not familiar. Astra, maybe. All right, question 4. Which NoSQL database organizes data into tables with rows and columns? Relational, tabular, document, key value, graph, or Microsoft Excel? Remember, which NoSQL database? Relational is not a NoSQL, so that's incorrect. But yes, tabular is the NoSQL database with rows and columns. All right. Let's see what that puts us. Millie's the fastest again. Yanga maintains first place. The Myrdal is still in third. It's still anyone's game, though. We have just a few more questions, so anything can change. Which NoSQL database is better suited for finding the shortest path between entities in a network? Traversal database, document database, graph database, key value, or tabular? All right, yes, most people got that correctly. It's a graph database. I guess the keywords would be entities in that question. All right. Just a couple questions left. I think 2 more. Myrdal was the fastest. So that one takes second place. Millie is still in the running though with third place. All right. A key value database supports complex relations and joins, is perfect for simple key-based data retrieval, is perfect for doing complex analytics, or always stores valuable cryptographic keys. I think this one should be pretty easy. Is perfect for simple key-based data retrieval is correct. All right, Myrdal takes the first place, but we still have the consistent top 3. Let's see if it all changes with the last question. What format does AstraDB use to store and retrieve documents? XML, JSON, HTML, binary, or tabular? Yes, JSON is the correct answer. And let's see where that puts us. If you are in the top 3, make sure you take a screenshot of your final screen so that you can email it to Gary Harvey. Congratulations, Virdal, for first place, and Yanga and Millie are second and third. Make sure you take a screenshot and then you can email it to Gary Harvey. There will be a message on screen and in the chat in just a bit. Yeah, so a final question. This is outside the game. If you want to answer this quick little survey, what did you like the most? What should we improve? We're always looking to make these workshops better. So I'll leave this up while we continue on with the closing thoughts. So if you were one of the winners, congratulations. Send an email to gary.harvey@datastacks.com. Include the screenshot of your Menti screen. If you need me to go back to get that screenshot, let me know. And we'll send you the swag, and we deliver worldwide. So doesn't matter where you are, we'll get it to you. All right. So if you are interested in earning the badge for today's workshop, you can do the homework. If you type in !homework, you'll get a link. It is also included in the GitHub repo. And it should be fairly simple. It's just kind of proving that you have gone through the content and understand it. And we will issue a badge for you. Oh, that slide is a little bit misformatted, but yes, the homework is on GitHub, and you'll be prompted for a form. You'll submit the result, or submit the form with your results, and then you'll get the badge. We also offer certification for Cassandra. And we are offering vouchers for attending this workshop. So if you go to that link, dtsx.io/workshop voucher, which I think we can get a link in the chat as well, you can redeem for vouchers that are valid for 3 months, 2 attempts, and they're usually around $145 each normally. So if you want to get certified in Cassandra, that is a great opportunity. We have several different tracks for certifications: the administrator, developer, or the Kate Sandra Kubernetes tracks. And we also have a lot of resources on datastacks.com/dev, and you can take different courses that will help you with your learning on that on those topics. You can also go to academy.datastacks.com for more courses. DS201 is really comprehensive, and then we have some more specifics for each of those certification tracks as well. So check that out. And once again, our Discord channel, if you have more questions about either today's workshop, or if you're going through other workshops, pre-recorded ones, or even if you just have regular development questions, this is a great community. We have more than 18,000 users already, and we're ready and waiting to answer your questions. And finally, if you want to subscribe to our YouTube channel, you can be notified of any new workshops that come out, or you can take a look at all of the past workshops and AstraDB specific videos that we make about different features and how to do things. It's a great resource, and we would love to share that with you. So take a look at that and consider subscribing if you find it interesting. With that, thank you so much for joining us today. I hope you learned a lot, and we had a lot of fun sharing that with you.
Thank you.
All right.
Hope you come
Goodbye.
back. Bye-bye.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.